This video is to go over homework 4D lesson 4.15, problem number 7. Says the sides of a triangle have lengths 4, 5, and 8, and another triangle similar to it has one side of length 3. So it should be similar to that, but it says one side has the length 3, but that doesn't mean it's the same side. Sorry. So that's actually 5. So 3 could be either here, here, or here. Okay? So you should consider 3 cases. So let's say we have, let's consider one case and you do the 2 other cases by yourself. So if 3 corresponds to 4, then the scale factor will be 3 over 4. Right? Because 4 times 3 divided by 4 is 3. So you have 2 rules, right? So you do that for the other segments. So 5 times 3 divided by 4 will be 15 over 4, which is about 3 3/4, right? And then you do the same thing for 8. 8 times 3 divided by 4, that's 6, because 24 divided by 4, so that should be 6. So that's one case. But what would happen if 3 does not correspond to 4? If 3 corresponds to 5, right? The rule will be, how can you make 3 out of 5? You multiply 5 by 3 and divide by 5. That's going to give you 3. So the rule should be multiplied by 3/5. So you should do the same thing for, 4, and you should apply that rule to 4 to get that length right there, and also apply that 3/5 to 8 to get another length of the side. The problem number 8 should be solved in the same way as problem number 7, so I'll skip that. Problem number 9, in the figure at the right, triangle ADE is congruent to triangle, not the triangle, angle. ADE is congruent to angle ACB. Explain why triangle ADE is similar to ACB. So let's take that triangle outside, and we want to prove that why triangle ABC is similar to triangle ADE. So we can use either those triplets, double A is actually not triplet. We can use the similarity theorem, either AA or SAS or SSS. Since angle ADE is congruent to angle ACB, we should either use double A or SAS. So which should be good? The length is not given, so maybe we can use double A. So in order to use double A, we need to find one more congruent angle to prove that triangle ADE is congruent to ABC. Problem number 10. In the figure at the right, AB equals 1, BC equals 2. AB equals 2, BC equals 1. Without making any measurements, find the values of AD divided by DE and AF divided by FG. Explain how you get your answer. So you might wonder, what's the length of AD and DE, right? But we don't really have to know those things, because we know that the ratio should be the same, because triangle ABC and ADE are similar triangles, because we have one angle, we have two congruent angles. See, one right angle, and angle A will be the same as Same for triangle ADE and ABC. So we have two congruent angles for those two triangles. So they're similar. If they are similar, we can use the proportions. So AD over DE should be the same as AB over BC. Or AD divided by DE should be the same as AB divided by BC. And we know what the AB divided by AC, so that should be exactly the same as the other one. Did I give you too much hints? Probably I did. Problem number 11, draw a non-isosceles right triangle ABC. Draw the altitude from the right angle to the hypotenuse. So hypotenuse is AC and the right angle is B. So I'm going to draw hypotenuse from altitude from vertex B to the segment AC. Now we have two triangles inside. Let's call that D. We have two right triangles, ABD and BCD. Now part A says there are two pairs of congruent angles other than the right angles in your picture. Find and label them. So you got ABD and BCD. There should be two more. There should be a pair of congruent angles. Which one is that? Is that angle A or no? Part B, make a copy of your triangle, then cut out the two small right triangles, position them in such a way as to convince yourself that they are similar to each other. So make a copy of it, cut it, and put it on top of each other so that you can convince yourself that whatever the claim you make for the part A is actually true. Part C, explain why all three of these triangles are similar. So we have triangle ABD, BDC, and we have ABD. So the question says these three triangles should be similar, but why? Definitely you got to use triangle similarity theorem. Problem number 12. In the figure at the right, AB equals 4, BC equals 5, AC equals 6, DC equals 2.5. So let's draw the figure. No, that's not it. Should be something like this. AB equals 4, BC equals 5, AC equals 6, and DC equals 2.5, EC equals 3. Prove that triangle ABC is similar to EDC. Right? Again, you got to use either AA or SAS or SSS. So use the similarity theorem to prove those two triangles are similar. Problem 13. Quadrilateral RATS is a trapezoid with RA, segment RA is parallel to segment ST, diagonals RT and AS meet at O. Explain why ROA is parallel to TOS. I'll give you a hint. The parallel lines and transversal gives us some kind of evidence to items to prove that they are similar, either AA or SAS or SSS. From part A, you can say that RO divided by TO equals OA divided by OS and explain. Well, because corresponding parts should be proportional. That's a hint. Part C, Mary Elizabeth knows that RO divided by TO equals OA divided by OS, and angle ROS is congruent to angle TOS. She claims that triangle ROS is similar to triangle TOA by SAS similarity test. Is this true? Is this true? Again, if you want to say SAS, the A angle has to be included, so that's the hint.